I chose the book because a colleague told me to choose this book, and I get weirded out by some of their questions. But this is one of it. Find the rule of the product of the function f times. They just want you to multiply the two functions. They could have just said multiply the two functions. So it's bizarre that they asked it in this way. So this is what it looks like. Those red things there mean that those numbers change for each person. So, you know, if you get tired of looking at your own problems, you can go to one of your neighbors and ask them for their problems. They'll get different numbers and they'll have different answers, and you can try another problem. So that's all they want you to do. They want you to take that 3 sine t and multiply it with sine t plus 5 cosine t. And if you do the distributive law, 3 sine t times sine t is 3 times sine t squared, and 3 times sine t times 5 cosine t, the numbers group together, so you get 15 sine t cosine t. Last time I taught pre-calc, people dropped the t's. Absolutely makes no sense if you drop the t's. The sign is something you stick the number into. So you need an argument for the sign. It's not, sign by itself means nothing. So make sure you put the t with the parentheses, otherwise it makes no sense. And last, but very important, this confuses my calc students too. This square, they always put the square right here. But what that square means, it means take all of sine t, take the sign of a number on your calculator and square your answer. So take the sign first and square your answer. So these two things are the same. So in calc class, we always had to take this thing and revert it back to this so we can actually do some algebra with it. So that's what the two mean. And you can see that the green key, which has the right answer, it's exactly the same as we had. So WebAssign is right yet again. Again, this is a multiplication. They just want you to multiply the two functions, f and g. And I believe, so WebAssign uses a computer algebra software to multiply things out, and I believe that's not what they wanted. I think they wanted you to FOIL it out. So let's do that. Again, notice on the side they said that little n, if you take sine raised to a power, that n comes down. That's just notation. That's what it means. Okay, so here's what they wanted you to do. They wanted you to take ugly mess number 1 and multiply it with ugly mess number 2. So FOIL it. That's what you have to do when you have blah plus blah times blah plus blah. FOIL, first 2, outer 2, inner 2, last 2. So there's your first 2. Nothing cool here. Nothing can come together. It just stays a sine times cosine. So you can't put the 6's together. It just sits there. Then we take the outer 2, sine times cosine squared. Can't do anything with it. Just leave it. Then you take the inner 2. Cosine to the 4th times cosine t. You can't put those together either because the insides are not the same. So this number is completely different than this number, so you can't combine them in any way. And then last 2. Cosine to the 4th times cosine squared. And that you can put together. Cosine to the 4th times cosine, I just copied and pasted the previous line so you can see it, is cosine to the 6th. All I'm doing here is adding those two exponents. So this is like x to the 4th times x squared. You would add the exponents together. So you add these to get 6. One step back. You see Mr. Smiley here? Smile, nose, eyes. Mr. Droopy eyes. Okay, any questions on that? It's messy, but it's still the same process. See, it's still the same. FOIL with messy objects. Close your eyes to the mess and proceed. Okay, one more and then I'm going to stop the video so that we have a small enough module. So here they want you to factor. There's a tan in both of these. If it bothers you to see the tan, think of it as x cubed minus x. You know what to do with x cubed minus x. You know why? Because you're used to it. Because you did a lot of that. You just got used to it and you're not used to seeing it as tan cubed plus minus tan. But it's still the same process. You'd factor out a tan to the left, and then what would I have? I always do, I think backwards. I got to make sure to get back to where I'm back at if I multiplied it out. Multiplying out is easier than factoring it back. Why? Because you've multiplied for longer than you've actually factored, so you got used to it for a longer period of time. So tan times tan cubed makes the tan times tan squared makes the tan cubed right there. So I'm thinking backwards. Tan t times -1 is negative tan t, so it gets me right back to where I started. So as I'm doing the factoring, I'm also doing the checking at this point in my head, because I do math every day, so I'm really used to it. And I just check that it works in my head as I'm going. So I'm always doing this cross check in my head. Does it multiply back to where it's supposed to? Good. Okay, any questions on that?